South Korea, and today's presentation title is the seasonal heavy rain forecasting method. Actually, the presentation is prepared for the additional result, except including the heavy rain and something like that. And I will show this result by presenting this this conference, okay? And and this is the whole content of my presentation. I want to share my introduction and based on the problem definition and the goal of this study, and then I will show some preliminary knowledges about this study, and I will briefly show about the proposed method and explain some data set which is collected by me, and finally I will show the experiment result and the conclusions. Okay, the main goal of this study is to support the forecaster's decision making on the 7 dangerous weather forecasting. That means the hazardous weather forecasting, okay? And such as the heavy rain and heat wave and strong wind and windstorm, heavy snow and cold waves and lightning, which means the thunderstorm. And based on these 7 hazardous rain forecasting, and with this additional helping, the forecaster can do more efficiently decision making. So based on the past cases, that means the weather map, and we create a forecasted time, region, and SVM models for each dangerous weather, and develop a system to determine the whether there is a dangerous weather according to the model using this. So the main method is like this. We firstly data extract and attribute combinating. Which attribute is more impact on the forecasting the weather. And then we train and test configuration, and finally we may show the hazardous weather prediction through based on the SVM learning and the classification. And the key requirements of this study, we firstly collect the past diary from 2002 to 2011, right? And each hazardous weather, as I mentioned, the 7 hazardous weather, and stand and case information. So the station information corresponding to the areas based on the city of Providence, and V means the point and the branches and so on. So the expected output is based on the SVM model, the hazardous weather determination result for each dangerous, that means hazardous weather by region and predicted time. So the main preliminary knowledge is the SVM model, and many of you, I expect that many of you already know about the support vector machine, which was one of the famous method, actually the linear classification sort of, but so I want to summarize briefly with this preliminary sessions. And as you know, the SVM is one of the supervised learning, right? That means we need a labeled data, right? So we also prepared and collect some weather maps, weather maps based on the professionality forecasters, and they labeled which is the hazardous or not. Okay, and for the data analysis, sorry. For the data analysis and pattern recognition, we use the SVM manners, and we can use these SVM models by the classification, and we also use this for the regression analysis. Especially we called it support vector regression. Okay, and classify the data by creating some hyperplane on some hyper spaces, right? So this is very simple concept of the SVM. We can denote this this gray one as a plus labeled and the white one for the minus labeled, right? And the main purpose of this example is find the linear boundary, right? So we have many data points in the, for example, two-dimensional space. And how can you make the linear boundary on this set? And it could be, right? How about this? It could be. And how about this one? It could be, okay? And there are many candidates, right? Like this, but which one would be the best linear boundary of this space? And as we know that, and we can compare these two different boundaries, and we can find some margins, right? And margin means the width, which shows the margin literally on this linear boundaries, right? So which one is better for us? Obviously, and the second one is better for the unseen data, right? So if we have another data point, the gray on here and there, with the same on there, and the second one would have more general and robust models. So I'd rather say the second one is the better linear boundary for us. So the SVM algorithm will find the optimal boundary with the maximum margins like this. So it will be very effective to classifying, especially on the binary classification, right? And so the algorithm conclusions, the SVM has a good generalization property. So the overfitting can be controlled by the soft margin approach. That means we can allow some errors through these margins, okay? And it is very nice it has a nice math property. So if we have a problem by defining a simple convex optimization problem, which is guaranteed to the converge to a single global solutions, it could be solved by the SVM, right? And it also has an ability to handle large feature spaces. So generally, we have a very high dimensional features, right? So the complexity would be depend on the dimensionality, right? But we can handle this one by using the kernel trick, right? And the sparsity is the solution when dealing with the large data set. So only support vector machine are used to specify by separating the hyperplanes. So with this SVM algorithms, we propose this method And this is the whole architecture we have building on the system. And there are two big modules. One is for the server side, and the other is the forecasting server. It's sort of the client in front of the server, main server. And the server system will keep the smart forecasting system on these machines. And the forecaster, as a user, forecaster will request a query to the smart forecasting system and receive the answering from the servers, right? And the smart forecasting system will send the query to the SVM-based heavy rain forecasting server. And I show the heavy rain on here, but we can use the 7 different models for the various hazardous weather for the weathers. And on this forecasting server, we implemented SVM modules on here. And this is the more details about the SVM model. And the model will use the user's input, and there are two different models. One is the data extraction module, and the other is the feature combination module. So there are many features and candidates. We can make the best combination with these feature combination modules. And then we make some cross-validation modules with this module. We may generate the SVM modules and verify it. So we can pick the best model through these CV modules. And with these modules, we may get an output, make an output. And the next slide, I will show the more specificity and the scenarios with these SVM modules. And this is the model training and test of our systems. And we can training with this vertical line. And for the training, we use the input as with this test weather maps, right? And the maps will be labeled by the alarm and non-alarm. Alarm is the hazardous weather, and non-alarm is for the normal weather, right? And we can use the SVM model. And if we select the optimal SVM forecasting model, and we use the current weather map as a query of the current time. And then finally, we can make some outputs by the different time. After 6 hours, after 12 hours, after 24 hours, that means 1 day, right? So this is for the candidate to help the decision making of the each forecasters. Okay, and now I want to show about the data set which I used for this study. And for the data description, we use the standard weather map format, which is the ECMWF. There are two kinds of degrees of it, and we used all of them from 2002 to 2011. And we reanalyze these things in the format, UMN 512 format. Then we divided the district divisions, and heavy rain is divided by the states, and the storm is by the point, and heavy snow and strong wind and cold waves and heat waves and lightning, something like that, is divided by the cities. Yeah, it is because about the data point, the collecting point is on that the divisions, right? So this is the data, weather data area. And there are, this is the whole world map, and we can get our data set from the nearby the South Korea, and we have a 22 for 228 and by 257 pixels grid map, and especially we focused on this the South Korea part. Okay, and we use the 30 by 30 maps pixels for the predicting after 6 hours, and we enlarge data set, which is the 40 by 40 is prediction for the 12 hours, and heat wave and cold wave, something like that. And for the 20, after 24 hours, it means 1 day, predicting for it, we use the 40 by 40 maps. Okay, and use the we use the attribute, the 5 attributes. One G, T, R, U, V attribute, and G means altitude, and T means temperature, and R means humidity, U and V means some wind. U wind is the for the directions. U and V is for the directions. Okay, and also isobaric surface used for the 3 hectopascals, which are 500 hectopascal and 700 hectopascal and 850 hectopascal. And for the experience, we use the 5-fold cross-validation for the training and select the optimal models. Okay, find the optimal models. And we divided all the data set with the 5-fold, and we trained, use the 4-fold, and the last 1-fold for remained for test set. And we changed all the test sequences like this, and we averaged all these validation score for the model performances. So with these things, we combine every possible candidate of the models, and we can finally find the best performance model by this cross-validation manner. Okay, and the evaluation metrics, we use the 4 evaluation metrics. One is accuracy, and the second is the false alarm rate, and the third is point of detection. That means sort of precision, and the fourth is the critical success index, which can be calculated by this complex combinations. Okay, and first result is for the heavy rain. For the after 6 hour predicting, the combination properties of UVR at the 850 hectopascal shows the best result, and the best result is almost 80% based on the accuracy, right? And after 20 hours and after 12 hours and after 24 hours, U value and on the 850 hectopascal single attribute is the best performances for the result. Okay, and second, heavy snow. For the heavy snow, we also have experimented with 6 hours, after 6 hours, and for the after 12 hours, and after 1 day. Okay, and when we using the attribute combination, is a good result is most regions. So the maximum accuracy is almost 86% based on the accuracy, and we can more lower accuracy for the predicting for the 12 hours and 24 hours. And for the thunder wave, it means lightning. And we also examine for the after 6 hours and 12 hours and 24 hours, the maximum accuracy is 75, almost 80% based on the accuracy. And at the same manner, we do the strong wind. We can also show the after 6 hours, after 12 hours, after 24 hours, the maximum percentage accuracy is almost 88, 89%. And the storm also shows the more accurate than the other hazardous weather, and the storm accuracy would be almost 97%. And heat wave and cold wave also shows the high accuracy result. I can tell you about the heat wave shows the maximum accuracy almost about 90%, and cold wave shows the accuracy, maximum accuracy about 80.66%. Okay, and as a conclusion of this study, we show the implementation of the predicting some hazardous weather based on the SVM algorithms, and our goal is to predicting the weather, hazardous weather after 6, 12, and 24 hours. And as your expectation, the predicting 6 hours is more accurate, but we can have acceptable accuracy using for the 12 hours, after 12 hours, and after 24 hours. And our goal is to support the forecasters' decision making on the 7 hazardous weather forecasting. Okay, and the experience using the about 20 years cumulative weather map was run with sub-vector machine and testing and using correct answers for the heavy rain and non-heavy rain. So by considering the experience result, it was found the hazardous weather prediction of SVM shows the accuracy rate of up to the 90%. Okay, and this is the end of my presentation. If you have any questions about this, and please feel free to ask